Good morning. In your math class today, you're going to be learning about box plots. Box plots are the last way of representing data that you're going to learn about in section 1. So histograms are a way of dividing your data into little intervals and making a bar graph out of that. Dot plots are a way of keeping your individual data and making a dot to represent each individual data item. A box plot is a way of looking at how your data is spread out among the quartiles. So the first step for making a box plot is you would put your data in order. So I'm going to start with 60 because that's the smallest one I see. And I'm just writing my data in order.
Now community buildings up to level 200. Only 200 slots.
Okay, here are all of my data in order. Now, the next thing you do with a box plot is you make a number line similar to how you would do a dot plot. So my data goes from 58 to 74, so I'm going to start my number line at 55, and I'm just going to count by fives.
Only 30 less factories.
It's important that even though your data might not be spaced out evenly, your number line needs to be spaced out evenly. Okay. Next, I'm going to find the median. So the way you find the median is you look for your middle value after they've been placed in order. So that's why I started off by placing them in order. So my middle value is 66 because there are 5 values less than 66 and 5 values more than 66. So that 66 is going to show up on my box plot as a vertical line at 66. It's going to be right in the middle of my box plot. Next, I'm going to find the first quartile. The first quartile is the number that divides the bottom half of my data in half. So the middle number of just the bottom half of my data is 63. So I'm going to choose 63 as my first quartile number. Again, I draw a vertical line to represent that first quartile number at 63. Then I'm going to look at the third quartile number. The third quartile number is the number in the middle of my top half of my data, so that's going to be 69. So I'm going to draw a vertical line at 69. And those three numbers form my box of my box plot. So this is my box. And I know that half of all of my data is in here. And it's not just any half, it's the middle half of my data. So it's the part of my data that is the most average is going to fall inside of that box. Then the next thing we do is we do the whiskers of the box plot. The whiskers are the minimum value, which is 58. So I'm going to plot 58 as a dot and turn that into a whisker out to the box. And then the maximum value, which is 74. So I'm going to plot that as a whisker.
Oh yeah, only 46.
And I also know that half of my data falls out here. So these two together make half of the data. But these are the extreme, this is the extreme half of the data. These are the very low and very high values. The question asked me for the top 25% in a talent competition. So the top 25% are going to be the ones in this whisker. So your data, the thing that a box plot does for you is it divides your data into quartiles. You know that 25% of your data is on the very low whisker. 25% of your data is in the bottom half of your box. 25% of your data is in the top half of your box. You can only get 5 actual values from a box plot. And even then, it might not be an actual value because remember, I happen to have 11 contestants, but if I had 12, I would have had to take an average of 2 values to get the median. You can only get 5 numbers that happened in your data from a box plot. You can only get the median, the first quartile, the third quartile, and then the maximum and minimum values. And so you lose a lot of information in a box plot. What it does for you is it lets you visualize kind of how your quartiles are spaced out. Even if this box is a little bit bigger than this box, that means that this quartile of data is spread out a little bit more than this quartile of data. So this one actually is pretty evenly spaced. It's just that this one is a little bit wider than this one. It doesn't mean there are more people in there. There are definitely not more people in there. There's always 25% in each one. But your numbers are spread out more in that region. So that's a box plot overview. You will be doing that in your math class today.